begin when you're ready.
Can I start now?
Yes.
Okay. Good evening, everyone. Welcome to discussion number 4. I hope everyone has completed the homework 1 and submitted it on time. I'll be discussing something about the homework policy in this discussion. I have a lot of slides actually, so I might be going a little faster. So if you can't understand something, just stop me and you can ask me any question. Okay? Okay. So this is the outline. I'll make some announcements, just some general guidelines, and I'll clarify some late homework policy. And I'll talk about academic integrity. Even though I talked about this last time, I think I want to stress upon this again in this discussion. And most of the talk will be on the homework 2 problems. So I'll give you some hints on how to go about solving the homework 2 problems. So for the announcements, I think one thing is please watch out for emails or announcements from TAs. I think some students miss the announcements and they tend to ask us some questions either related to the homework assignment or regarding the homework submissions. So keep a watch out on emails and any announcements from the TAs. And also visit the discussion board regularly because sometimes your questions might be already posted on the discussion board and you might have already answered it there. And so before emailing the TAs, please visit the discussion board and find out if your question is already answered there. Because it will save time for both of us, both for you and as well as the TAs if it's already answered. And one strong suggestion is please start your homeworks early. I guess most of you have finished on time, your first homework, so I hope you had 1 day rest yesterday. So if you're ready, you can just start homework 2 now. So you start early because you can finish it on time. So you don't have to do late submissions. And one recommendation is submit at least 1 hour before the deadline because you might encounter some last minute internet connection problems. So if a lot of students are trying to upload at the same time, so the deadline might be a little slow actually. So we suggest you to submit at least 1 hour, if not 1 hour, 30 minutes before the deadline. And if you encounter any problems, you can email the TAs and the graders and the TAs so that your homework will be counted as on-time submission. And for the late homework policy, Professor clearly discussed this in the lecture 1, and I would suggest you to watch the lecture 1 again for more details about this. I'll just talk about late homework, the late homework submission links in this slide. So the main thing is this course has no late homework policy actually. So it's a little different from other courses in the sense that you're not allowed to submit late homeworks, but Professor asks us to collect some late homeworks. In the sense the late homeworks is not your entire homework should be late, but some parts can be late in the sense that say you've finished problem 1 and 2. So you need to submit problem 1 and 2 before the deadline. And then if you want to complete the problem 3, you can complete it and submit after the deadline. And we have created late homework submission links on DEN. So you need to upload your late homework updates only at these links. So any submission made at these links will be considered as late. And we recommend you to finish the homework on time, but in case due to something which you're unable to finish it, you need to submit the update parts only at this links actually. And so the late homework policy is a little bit different in this class. So you can submit the updates, but it's not guaranteed that it will be graded. So Professor will make a decision at the end of the semester depending on how the pattern of your late submissions. And also note that you can only upload 1 time at this submission link. You can't do multiple uploads. So do you have any questions? I sent out an email yesterday about this actually, about all this, the instructions. Do you have any questions regarding this? It's good then. So as I said, if you cannot finish everything on time, submit whatever you have before the deadline. and only the update should be submitted after the deadline. And there's no guarantee that the late homework updates will be graded, and it depends on professor course discretion. So the homework 2 is due on 13th October. So you have around, I think from now you have 20 days. So the suggestion is just start early so that you can finish on time. The homeworks will become harder as the semester progresses. So, and the homework 1 grades will be out hopefully this week, Friday, if not early next week. And the graders will upload the graded reports on the DEN. So we'll announce grading officers, and once the grading has been done. And for grading disputes, you can email the graders. And also we'll be sending an announcement about the regrading request form, which will be uploaded on DEN. So you can actually, you need to fill out this form before you meet the graders. So the graders have a copy of your queries. Do you have any questions regarding this? Yeah, there'll be an announcement hopefully by the end of this week about your grades, homework 1 grades. Okay, I'll just briefly talk about academic integrity because this is important. Any type of plagiarism is not allowed in the course. So I think in any course for that matter. So just do your own work and submit your own work. Even if you like work with a friend, but I mean, write your own report and your own code. Don't like share the code or the reports. And do not use work from your friends or from friends from previous semesters. The system is quite intelligent, so it can basically find out the similar copies even if you change the variable names or change some names. At the last resort, graders also check your codes manually. So be aware that just using some simple tricks is not good. So the main thing is you need to do your own work and submit your own work. So I want to also briefly talk about this on the citation. If you take some material from the internet, like Wikipedia, you are supposed to like cite it. I mean, even so, without citation, it's obviously a blatant violation of the academic integrity, and this is not allowed. And even if you cite at the end of the report, if you copy it verbatim, it's not allowed actually. So the best way is you need to understand the material and write in your own words. And even if you use quotation marks, like using quotation marks for referencing a definition or a formula is okay, but you're not supposed to copy the entire paragraph like this. So this is also actually not allowed. I'm telling this because we already found some students doing this. So this is actually a violation of academic integrity. Yeah, that's it about the announcements and the academic integrity. Do you have any questions? Yeah. Yeah, some definitions and equations are okay, but you need to cite the source. Yeah, some students have actually copied the entire paragraphs in the report, which is not right. You have any other questions? Yeah. Yeah, assignment is okay. That's fine. You mean an assignment sheet, right? Okay. From the problem sheet. Yeah, it's like a quiz. Yeah, those are fine, obviously. Any other questions? If not, I'll move on to the next. So, yeah, this is the main part of this discussion. So I'll talk about homework 2 problems and give you some hints. And if you have any questions, you can stop me and ask me your questions or your doubts. So some of the slides actually I made it for Professor Course, so you'll see the same figures, I guess. So the first problem, let me open up the homework problem. So the first problem is special effect image filters. This is not a very trivial problem, but it's not a very difficult problem. So the main thing is you're given a bunch of images. You need to basically do a pencil sketch for the given images. So we have different parts. So just to guide you on how to do this this problem. So let me go back and talk about this. So pencil sketch is actually a freehand drawing, generally used by the artist to draw portraits or any scenery etc. So this is for motivation, I'll just show you a video. This is actually a music video in the 80s. I hope the ad doesn't load. Okay. So this is an 80s video. All these are pencil sketch images. I hope you get the idea. So this is a simple example motivation for the problem in the entertainment industry. And coming back to the technology sector, so this the edge detection is actually a very common tool used in several problems to solve several problems. This is an example. So you have the fingerprint image. This is actually a latent fingerprint, which has a lot of structural noise, such as this line and these digits. So the main problem is to actually do some kind of pre-processing to segment out the fingerprints from these structural noises. So one simple technique is to use Sobel gradient map, which is actually a edge map, to identify the structural noises, strong structural noises, such as these lines and these digits, and basically remove them. So you can use some technique to actually remove the structural noises. So this is another example of or a motivation for why this gradient edge detection is important. So now I'll directly jump onto the problem and how to go about solving the problem. So I think for the first problem, we ask you to okay, I'll talk about this later. I'll talk about the edge detection first. So for the part 1B, you are supposed to implement two basic edge detection algorithms. One is a first order derivative gradient method, and the second one is a second order derivative plus zero crossing approach. So I'll cover these two things now. So the first order derivative, this is an example. So in this approach, basically you're trying to find a gradient, which is actually a first order derivative, and then basically find a gradient map and find the edge map from this gradient map. So it's actually a pretty simple procedure, pretty simple approach. So in this example, I'm showing you how to use how to generate an edge map from the gradients in the horizontal and vertical directions. So basically, you can apply a simple edge operator such as Sobel mask or Robert mask, and then basically you can generate the gradients and find the gradient map. So in this example, I'm showing you I'm giving an example of generating a gradient map using horizontal and vertical gradients. Basically, you will find the gradients. Since this image is a discrete signal, you basically find the difference, use the differencing operator to find the horizontal and vertical gradients, and then you find the gradient map using this formula, or which is actually the square root of the sum of the squares of the gradients. This is the magnitude, and basically you make a decision based on the magnitude of the gradient map. So which is actually edge is actually a binary decision. So based on a particular threshold, you keep certain points as edge points, and the remaining points you make it as the background, which is in this case I think is white background. So this is essentially the block diagram. So given the original image, basically you generate the gradient maps using simple convolution operator or difference operators, and then apply thresholding to find the edge map. And how do you define the threshold? Threshold is actually found using based on some histogram of the distribution of the pixels in the gradient map. So I think Professor covered this in detail in the lecture 3. And for the second order filter, second order derivative, Professor talked about 2 approaches, which is the Laplacian of Gaussian. It's called LOG. So the idea is before applying the Laplacian operator, you basically do a Gaussian filtering. This is the formula for that. And for the difference of Gaussian, this is nothing but an approximation of the Laplacian of Gaussian. So the idea is you're basically taking a difference of, you're applying Gaussian filters on the image and basically taking the difference of this Gaussian filters. I mean, that's the definition of the difference of Gaussian. The key thing is, the main idea here is basically your, so this DOG acts as a bandpass filter and removes all the frequency and only keeps the frequency in certain band and removes all the other frequencies. So here the edge belongs to certain frequency range, and that's the thing which you're basically keeping in the image. So this is the DOG. And basically to find so this DOG is nothing but a Mexican hat filter. So you need to find 2 thresholds. Actually here we just mentioned as 1, but you need to find 2 thresholds which can distinguish between the point of zeros, I mean the point where the zero crossing happens. Yeah, so the threshold, again, you can choose this by plotting the histogram. Okay, let me talk about zero crossing again. So actually, you have a zero crossing map in the textbook. This is a simplified version of that. So whenever you find a zero crossing, basically you need to check the zero crossing in 4 directions. This is an example. So if there's a hit with any of these 8 masks, basically you're setting the zero crossing map as an edge point, else you're setting it as a background. So this is the overall procedure or a block diagram for second order derivative. So what you're doing is essentially you have an original image, you find the Laplacian map or apply a DOG, and you get the zero crossing map. And in this zero crossing map, basically you're trying to find whether the particular pixel is the edge or not. And to find the edge, basically you're trying to compare this zero map with all these different filters, not filters, the masks. So if there's a hit with one of these masks, you basically make that as an edge point, else you make it as a background. So this is the overall overview of the second order derivative. Do you have any questions on the first or the second order? Yeah. So this is a binary image. So generally the edge map is a binary image, so you assign it as like 1 or 0 or 255 or 0, something like that. Yeah. Right. Right. Of the gradient map, exactly.
So, against what do you plot if it's not intensity levels?
So you have, in the gradient map, you have intensity levels, right? It's not just 1s and 0s. Okay. So it has like a range. So basically you plot the histogram of that range and choose a suitable threshold, like 95% or like whatever. So I think Professor covered this in the class. Yeah, one more question there. You can use the same approach. So, yeah. Yeah, it's quite robust, but so what do you mean it's not? Right. Because in the second order, the idea is you're finding the zero crossing. So the main idea here is the first order just tries to find a gradient, and essentially whenever there's a slope, when the slope is 0, you're trying to find it is like a maximum or a minimum, right? So for the first order, you consider that slope when slope is 0 as maximum, so you make that as edge point. So sometimes when you apply like Gaussian filter, you can't actually find out where the peak is. So you apply a second derivative to actually find a peak. You identify a peak when there's a zero crossing. So is it clear? Okay. Because in the second order, basically you have 2 gradients, right? One you have the increasing gradient and one is decreasing gradient. So then you obtain a zero crossing at the peak. Any other questions? Okay, then I'll continue. So coming back to the problem, so the first part basically says you need to convert a color image to a grayscale image. So this is the formula for that. So Y is the grayscale channel and RGB is the color channels from the color image. So it's a very simple process. So this is one of the standard ways to combine the red, green and blue channels to obtain a gray channel. I don't know why this thing. Okay, so for the second part, this is the important part. So here we are asking you to use the edge detection operators to actually generate an image which looks like a pencil sketch. So this is not this is one of the ways to do the pencil sketch image. So you can observe this is actually a gradient map. I've just shown you an example. So this is a gradient map. That's where you can see different types of intensities in this image, in the pixel intensities in this image. So you need to actually combine this with the edge map to obtain a better pencil sketch image. And yeah, you can also do pre and post processing for these images, because I think one of the images is a noisy image, so you need to apply some pre-processing technique to like denoise the image and then apply do the pencil sketch on that image. And okay, what happened to this? Okay, and that was okay. That was part B. Now part C is you need to add. You can add a simple special effect. So this is a composition of two digital images to obtain like a fancy image or a special effect image. So it's a very simple procedure. So given the pencil sketch image, you're trying to actually you're trying to combine the pixel intensity values of two different images to obtain like a special effect image based on, according to your preference. So in this example, basically you're varying the value of alpha and beta parameters and generating the output image. So I think we specified the range of alpha and beta. You can try different values and try to find out how the combination of the pencil sketch image with the grainy background and try to find out what type of results you obtain. Do you have any questions for the first three parts? Okay, then I'll continue. So part D is actually quite simple. So you need to actually generate a special transition effect. Let me open the assignment sheet. So you need to generate two types of transitions. So one is a simple sliding transition. Basically, you're trying to combine the original image and you're trying to transition from the original image to the pencil sketch image actually. So you can do the sliding in different fashions. So these are some simple examples. So if you want to design your own way of directions, own way of sweeping to the image, that's also fine. You can do zigzag, or you can do like fancy, like a spiral type of effect. That's also fine. But this, you need to implement two of these, any two of this. I would suggest one from this batch and one from this batch will give you a good way to like see different type of special effects. And for the second one is a simple fade-in transition. This is very popular in the in any music or in the movie videos. So the idea is basically you're transitioning from one frame to another frame using a simple additive combination. So basically you're trying to remove pixels from one image and try to add pixels from another image. That's the main idea here. So this is a snapshot of the sliding effect. So you can see this is the original image and this is the pencil sketch image. So I'm sliding from this direction. And yeah, and this is a fade-in example. So this is a small video. So you can see that one of the intensities, the intensities from the color image is changed to the intensities of the pencil sketch image. So this is a simple transition, fade-in effect video. Do you have any questions? Sorry, I should have. Yeah. Yeah, that I'll cover in the next slide actually. So this actually I'm giving you a kind of a pseudocode, like how to do the stitching. This is for the for both any of the transitions or stitching images. I think here I'm telling you how to generate a video, not stitching of images. Stitching of images is made in your own program. Basically, you try to like copy the pixels in whichever order you want. So, are you clear about that? So, okay, let me give an example. So, this is the image, right? So, you want to basically do a sliding effect. So, this is the original image. Something looks like this, and the pencil sketch image. So, what you want to do is basically you need to stitch these images. You need to combine these images. So, in this problem, the main thing is we tell you how to like sweep through the images. So, if you're sweeping from this side, essentially you're replacing all these columns with the columns of the original image, that is this, with the columns of the pencil sketch image. So this is a simple way of sweeping. So it's just like a combination. You're just like replacing one channel with the other channel. That's all. Is it clear? Yeah. Oh, combine the yeah, that is in the next slide actually. Yeah. So this is an example for the MATLAB code. I think you can do similar thing in the C. I don't have it right now. Probably we can give some example in the next discussion class. So for the MATLAB, you can actually, they have some inbuilt functions. So you can, for this homework, you can use the inbuilt functions to generate your own videos for the movies. So if you want to find more descriptions about these commands, just like type help this function name in MATLAB, and it will give you like a explanation or description of what this function does, and also gives an example of how to use this function. So you can use these functions for this homework actually. So this is an example. If you want to use some other functions, it's also allowed for this homework. And the functions related to like generating a video is allowed, not in general. So this is an example. So in this example, basically you need to create an object for the video. I just call it a movie object. And basically you need to open, it's like opening a file, it's like opening an object. And basically you need to do the image processing, and you need to basically write into the video. So what's happening here is you need to open the object here, and next you need to have a way to like copy the image into a format which can be written into the video. And this is actually one of the formats. So this is called as the frame. So you can create a structure. The C data is actually a type of data structure which basically captures the frame information, the frame information into the video. So it's quite simple actually. So you need to create this temporary variable to capture the frame, and you can do some kind of image processing here. And get frame basically captures the image you have generated in this step. So say you have combined your stitched two images, like the pencil sketch image and the original image. Then you can use the get frame get frame command to actually capture this whatever image you have generated into this into this variable, and then write this temporary frame variable into the movie object. And yeah, you can also like adjust the how many frames you want to write and all those things. So you can look up these functions, and you'll get more information about that when you like use help on MATLAB to find descriptions about these functions. And after doing this, you need to close the object. And then you can actually play the video in the MATLAB itself using the movie command. Okay, this I was just like trying to just view one frame. So you can actually use the entire video. So whatever video you have, you can input here, and you can basically play the video. Do you have any questions? Yeah. Sorry? Yeah, I know, Gil. But I would suggest you to make videos. That's the thing we ask in the problem, right? Yeah. If you're interested, you can make GIFs as well for your purpose. Yeah. So it's not needed. You can copy the files. I mean the images. You can create the images in the C, and basically you can call them here, and basically you can do this. So you can basically open the image file in the MATLAB, and then basically you can do these operations. So there's no problem with that. Any other questions? This is quite, yeah. This is the image, right? So, I mean, this is a video. So we would suggest you to use one of the standard video formats, coding format. Oh, this one? Yeah. So when you, basically it needs a matrix here essentially. So, yeah. Right. So you can convert the grayscale to RGB. In this case, it's a simple, you copy the grayscale on all the 3 channels. It still is a grayscale image. Looks like a grayscale image, but it's a color image. Any other questions? Yeah. Okay, then I'll continue. So bonus question is actually quite challenging. This is actually an example of how the color pencil sketch should look like. I don't know if anyone can generate this. If you can do, it's actually very good. Yeah, I don't have any hints for the color pencil sketch as of now. Professor already gave some hint, but there might be some problem in that approach. So you need to figure it out how to improve the color pencil sketch. This is the bonus part actually. If we have time, I'll go over one approach where we can try to generate a pencil sketch image, which is similar to what Professor Ko already talked about in the class. Okay, then I'll continue for the problem 2. So in the problem 2, let me open the assignment sheet. So in the problem 2, you need to perform 3 types of morphological operations. One is shrinking, and the other one is thinning, and the third one is skeletonizing. I think Professor covered this in the last class, but I'll go over how to do the morphological processing in this discussion. So in the first, in the part A, the first problem, you need to do the shrinking to basically count the number of stars in this image. I think which is quite challenging. So this is the image, and essentially, can you see this? Okay, yeah. So in this image, you need to find out the number of stars in the image. Okay. I think Professor touched upon these examples, but this problem, but I'll mainly talk about how to go about doing these 3 approaches. That's shrinking, thinning, and skeletonizing. So before doing this morphological operation, you need to do some kind of pre-processing. So the given images are in color images. So you need to basically do a binarization of the image. So first you need to basically convert the color image to grayscale image and then do the binarization. And as Professor already told you, you can try 2 approaches. One is a simple approach where you keep a 0 as a 0 and convert all the non-zeros to like 1. And also use the advanced approach. So I would suggest you to do both approaches, and you will see why this approach is more useful to find the right answer. So advanced approach is basically you need to use a histogram to find a threshold on how to binarize the image. That is beyond certain threshold you can keep as make all the non-zeros as 1, and below certain threshold you can make all of them as 0 or the black pixels. Yeah, and as Professor suggested, you need to try multiple binarization approach and try to discuss your solutions on all these different binarization.
The time is 5 o'clock.
When I say multiple binarization, I'm telling try different thresholds for the advanced case. And for the first problem, for the part A of the problem, we ask you to find the star size and the frequency. And the hint which I can give you is when you're doing shrinking, you can actually find the star size and also like and also have a counter to find the frequency of the stars of different sizes. So now I'll talk about the morphological processing. Some motivation for this problem. So it's basically used to extract and analyze geometric structures in the images, digital images. It's mainly used for pre-processing. One example I already showed you. It's also used for doing structural modification, for segmentation, and a lot of like pre-processing techniques, which is useful for image processing and computer vision. So this is actually a very useful tool. So if you know this tool, you can actually use it to do some pre-processing, then do advanced like image processing or computer vision techniques. And in this class, you are actually learning the techniques for binary images, because you convert the grayscale to binary and then do the morphological processing. But actually, this can be extended to grayscale images, and which is a little bit challenging. And we are not teaching this in this class, so you don't have to worry about that. And this is an example. So coming back to the fingerprint image, so when you have a fingerprint like this, so you want to actually generate the ridges present in this fingerprint. One way to do it is you can actually do a skeletonizing or thinning of the original image, and basically you get some kind of contours and some ridges in the fingerprint image, which will be very useful for identifying some key points in the image and then doing the fingerprint matching. So this is a simple example. So now I'll talk about morphological processing. So some instructions actually. So you're not supposed to use, MATLAB already has some inbuilt morphological operations. I think C also, I mean, if you use some special libraries, C also has this option. But you're not allowed to use any inbuilt morphological operations. And you are also not supposed to use logical operators in the image processing sense. What I mean by that is you're not supposed to use dilation or erosion functions in the MATLAB or in C. But you can use like the logical operators such as like ampersand, double ampersand, and the double OR operators. These are allowed. But you're not supposed to use the inbuilt dilation or erosion operators. So these are some instructions. Then one suggestion is we have provided you the pattern table. I think Professor also talked about the pattern tables in the class. So basically, you need to like refer these pattern tables to do the morphological processing. And one key thing is you need to understand what each mask does, in the sense that given a mask, you need to understand what that mask is trying to capture, like whether it's trying to capture an edge, like an angle of the edge, or what type of like a filtering operation it's trying to do. And also note that in this pattern table, the masks, not all masks are used for all type of operations. There are some masks which are used for like shrinking, thinning, and some are used for skeletonizing. So you need to know which masks are used for which type of operations. And the table already specifies it clearly. So I'll briefly show about these tables as well in the future slides. So if you have any questions or doubts, you can stop me and ask me. I think we have 10 more minutes, so I'll give an example. Actually, I'll go through this and show a simple example. Okay, so the main procedure for morphological processing is it's a two-stage filtering approach. In the first stage, you basically use you can use a bond number to find which filters to match, and you'll be doing filtering or pattern matching in 2 stages. And you basically repeat these 2 approaches, these 2 steps until convergence. And as I said before, you need to like follow the pattern table carefully, and note that not all operations are used for, not all masks are used for all operations. And in the tables, they are denoted as STK. S is shrinking, T is thinning, and K is skeletonizing. And this is the block diagram of the morphological processing. So even the input image, which is F, you basically apply the conditional filters, which is the filter 1 here, and you obtain an intermediate masked image, and you apply unconditional filters to obtain the output. So basically what it's doing here is, in the first stage, you're trying to mark which pixels are you're trying to mark the pixels which need to be removed And in the second stage, you're actually removing the pixels. And basically, you're iterating this process until convergence to obtain the desired result. So this is actually the operations which you will be performing. Instead of showing this, I'll explain with respect to filters itself. It's much more intuitive. So this is again the same. This is the first stage. It's just like the first one iteration of the entire procedure. So basically, in the first stage, you're applying conditional filters to get the intermediate result and apply the unconditional filters to get the final result. So conditional filtering is straightforward. You're basically comparing the given mask with 3x3 windows surrounded around the pixel which you're interested to find out if it needs to be removed or not. So essentially, you will be centering the mask around this pixel and trying to match whether the neighbors around this pixel matches with the pattern in the table. And if it's a match, then basically you set that pixel as 1. In a new image, you need to construct a new image where you set that pixel as 1. Else, you basically don't do anything. In the sense, copy it as 0. So this is an example for the conditional table, conditional pattern mark table. Yeah. So this S is actually for shrinking. So bond number. I don't know if Professor covered this, but bond number essentially is used to find out what masks to use to compare with the neighbors in the original image. So here the bond number 1 corresponds to the 1 pixel present here. So all the corners, these diagonal corners have a value of 1. All the vertical and horizontal corners have the value of 2. So in this case, all these 4 filters, all these 4 masks have the bond value as 1. So when you're trying to compare, you first find the bond number, and if it's 1, you just need to compare with these 4 masks. You don't have to compare with the other masks. So this is like a faster way of doing morphological processing. So so the 3 is nothing but you have two ones here, and basically whenever the bond number is 3 because it's like the corner, diagonal corner plus vertical corner, horizontal corner. So 1 plus 2 is basically 3. You're basically summing up the values to find the bond number. And so this is the first stage of processing. And in the second stage, you are applying unconditional masks to basically scan on the new generated the image and either remove the pixel or keep it. So for unconditional mask, you need to refer to 2 tables. This is from the textbook actually. We also provided these tables uploaded on the DEN. So for the shrinking and thinning, you need to use the 14.32, and for the skeletonizing, you need to use this table. So this is an example. This is for the shrinking and thinning. Yeah, shrinking and thinning unconditional mask patterns. So the key idea here is this is the F-at image. So these are the marked pixels, and so you are trying to apply this filter, these patterns, to find whether you need to keep the pixel or remove the pixel to get the final one of the final images. So here M actually corresponds to the marked images in the marked pixel values in the F-at image. So I'm basically talking about this image now. So the first stage is this, first filtering is this, and this is the second filtering. So whenever there's a M, it means that it is marked, and if it hits with this pattern, basically you need to erase it. If it does not hit with this pattern, you need to keep the pixel. That is pixel in the sense I'm talking about the center pixel. So this is the procedure essentially. So for the unconditional step, basically the processing is done only if there's a hit at the center location. That's only when M is 1 in F-hat, and when the window is centered at IJ. So if there's a hit, basically you need to make it 0. The output should be 0. If it's not a hit, then you need to make it as 1. So just remember this. So sometimes people think, some students make the habit that if there's a hit, they make it as 1. Otherwise, they make it as 0. Just note the difference actually. So here, the second stage, you're trying to erase the pixel. You're not trying to keep the pixel. So because all these operations are essentially trying to reduce the size of the object, right? So shrinking is basically reducing the size of the object to, if it's a dense object, you're reducing it to 1. So you're trying to 1 point. In the sense, you're trying to reduce it to the center of gravity, something like that. And I think unconditional pattern masks are a lot in the sense that if you're trying to code up all the mask patterns, it might be a little difficult. Not difficult, it will be time consuming, I would say. So there's some neat trick to do that. Okay, before that, I'll talk about this. So in the unconditional, I don't have it here, unfortunately. So in the unconditional pattern table, basically you have some alphabets like A, B, C, D. So D actually stands for don't care, in the sense the value of that pixel will be 0 or 1. So you don't have to care about that pixel value. And for ABC, essentially if there's some condition such as A or B or C is 1, then it means that at least one of them is non-zero. This is like the logic OR operation. So only, I mean, all three can be non-zero, but at least one should be non-zero. That's the meaning. So for this case, you have like what, 7 combinations which can be non-zero.
3 minutes remaining.
Okay, thank you. So this is one example. So this is a mask. If you have this AB and this is one pattern, so basically this mask represents all these 3 masks in this one single mask pattern. So here basically we are trying to capture the values of A or B as being 1. That is A is 1, B is 0, A is 0, B is 1, and A and B both are 1. Both are 0 is not a valid mask. So you need to keep that in mind. So basically to enumerate all these masks is actually a little expensive. So Professor already talked about one simple approach to overcome that. So one simple way is you can convert the masks into bit streams or digits. So bit stream is basically a stream of zeros and ones. So Professor asked you can go in the anti-clockwise direction and represent this as a bit stream like ECB, this one. Or you can also do in this fashion, but you should be consistent with respect to the how you're comparing the masks. And you don't have to worry about the center because you only compare with the mask only if the center pixel is 1. So you don't have to worry about this pixel. So this is an example. So here I'm giving an example on the how to convert into a bit stream, and then you can convert into a digit actually. So I'm scanning in this order actually in this example. First this is a 0, then this is another 0. So this is a bit stream. So this is the final bit stream you obtain. You don't consider this pixel value, the center pixel value. So you can convert this into a digit. It's like a decimal value, and then you can basically compare this digits with the pixels around the neighboring pixels around the center pixel in the target image. And for unconditional mask patterns, so basically you have these type of patterns. So instead of enumerating all the different masks, you can basically generate a series of digits, a numerical value, which you can directly compare with the neighbors of the center pixel. So yeah, this is an example. Do you have any questions till now? I think we have only a few minutes left, so I won't go into the problem 3. I'll just stop here actually. So if you have any questions, you can ask now. We have like 3 more minutes. 2 more minutes, yeah. Any questions for the morphological processing? Okay, if not, okay. Yeah, okay, I think we can stop here. Yeah. Thank you for coming.